Hey 8th graders, today's lesson is 3.2 and 3.3 light waves. In our last 3.1 lesson, we kind of took a look at the pathway of light and what happens if light isn't absorbed. Okay, so up until this point or yesterday's point, we've talked a lot about, light can change an object if it's absorbed, but what about if it's not absorbed? So yesterday you guys did a little experiment and you guys got to see other interactions light can have or other pathways that light can take, including being transmitted through an object and coming out the other side, or reflecting off an object, bouncing and coming off. Today we're going to look a little bit more of what cause does that have or what effect does that have on an object. Do we see any changes if light is transmitted through an object or reflected off an object? Okay, so for your activity 1, you guys should have added key concept 11 and 12 to your key concepts page. Key concept number 11, a material transmits or reflects some types of light and not others. So obviously the kinds that aren't transmitted or reflected are probably absorbed. Okay, and then key concept 12, when light is transmitted through or reflected off a material, the energy is not absorbed, so the material does not change. Okay, moving on, your warm-up activity 2, examining light waves. The diagram below shows 2 different types of light shining on the same material. The type of light from light source 1 transmits through the material, and the type of light from light source 2 reflects off the material. Examine the diagram, then decide which light wave could be emitted from light source 2. Okay, so you guys should kind of recognize this, except our differences in what happens with our objects. Before we saw warmth in our object and we saw damage in our object, but here we see that the light's just moving through it. So we have this high amplitude light wave here. You guys can check out its frequency and its wavelength. Remember, its wavelength is from peak to peak. Okay, and it's going through that object. Okay, then we have a different type down here that's hitting it and reflecting. So what you guys are going to try to figure out is based on the different wavelengths. Okay, obviously we know that this is probably, B is probably not the answer because this is the same wavelength as above. So if this one transmits here, it's probably not going to transmit here or cause reflection. So B is out of the question here. So you guys are kind of choosing between A and C. So if you guys kind of compare the two, this one has about the same wavelength as above, but just a lower amplitude. And this one has a way larger wavelength, so therefore a lower frequency. Remember that those wavelengths with lower frequency also have lower energy, so think about that. Okay, so you guys will go ahead and mark A, B, or C, and then explain why you guys chose that answer. Okay? If you guys haven't finished up the warm-up or the activity 1 yet, go ahead, pause this video, take a second to do so, and then we'll move on to activity 3. Okay, for activity 3, you guys are going to revisit again 1.2 is that very first lesson we did in light waves, where you guys had 4 comments and you guys said where you agreed and disagreed. We've already kind of revisited number 2. And this one we're going to revisit number 3 and number 4. So if you guys really want to, you can go back, open up lesson 1.2 and check out whether you guys agreed or disagreed with these statements originally. Again, we're just looking at comment 3 and comment 4. Okay, but you guys are going to go and kind of piece together what we've learned since then. Okay, that was at the very beginning. Now we're in chapter 3. Okay, so third comment was all light can be seen. Do you agree or disagree with this statement now? Think about what you guys have done with the sim, what you guys have done with some of the little hands-on activities, and then explain your thinking here. So 2 questions for you to answer on this slide. Okay, same thing on slide 7, except you guys are looking at comment number 4. Okay, light can travel through materials that you cannot see through, like wood or aluminum foil. You guys tested this out yesterday with the aluminum foil, so think about what you guys saw as far as transmission, absorption, and reflection of different types of light. Okay, so do you agree or disagree? And then explain your thinking here. So 2 things you need to answer here. Okay, if you need to take a second, pause this video, finish activity 3, and then we'll move on to activity 4, which is a sim. All right, so activity 4. We're going to start by making a prediction, and this prediction isn't going to be something that we're necessarily testing in the sim. The sim's a little bit different, but I want you guys to think about this data that we see from the sim. So we have the aluminum foil, okay? We can see that we're tossing basically a light bulb at it. So we have visible light and infrared light hitting it, and it's reflecting off of it. Remember the little yellow arrows show energy. So the first question you guys need to answer is the image above shows light from a light bulb reflecting off aluminum foil. All of the light is being reflected. Do you think that the aluminum foil will get warm? Okay, remember that light waves carry energy, and these little yellow arrows are representing that energy. So circle yes or no, and then explain why you guys think it will get warm or will not get warm. Okay? All right, moving on to the sim. In this sim mission, you guys are going to find 2 materials that transmit green light and 2 materials that reflect green light. Okay, the other day we did an electromagnetic wave activity where you guys learned why you see color. I want you guys to think about what transmitting and reflecting would mean for what you guys see for a color. Okay, so again, your goal is to find 2 materials that transmit. So the green light's going to go all the way through that material and come out the other side. And then 2 materials that reflect green light. So that green light's going to hit it and bounce off. Okay, then you'll observe what happens to energy when light is transmitted or reflected. So when that green light hits it and either it goes through it or reflects it, what happens to the energy? Remember that when light hits an object and is absorbed, that energy is absorbed into that object, and we would see changes like heat or damage or whatever the case may be. Use your observations in this mission to help you answer the investigative question, what happens to energy when light is transmitted through or reflected off of a material? Okay, open the sim. And you guys are going to go to laser and set the color to green. So here's my sim. I'm going to go to laser. It's already set to green for me, which is convenient. I'm going to go ahead and turn that on. And then down here, you guys have the list of materials. Okay, so you guys are looking at plant, solar, glass, aluminum, melanin, and genetic material. So you guys will take your turn testing each one of those. Okay, so let's read through the rest of the instructions. So search for materials that transmit or reflect green light by dragging them to the platform in the testing area, one at a time. When you find a material that either transmits or reflects the light, do the following. Turn show energy on to observe what happens to the energy in the light. So you guys will click the little show energy toggle to see what happens to the energy of the light. Okay, remember that when light is absorbed by an object, that energy goes into that object. It's transferred into that object. So what happens when that energy is reflected or transmitted? What happens to the energy? Okay, so pay attention to those yellow arrows. Press inspect to observe whether the material changes. So if I test out a plant, okay, I see the light's hitting it, it's reflecting off. The energy's not going into the plant. Okay, so there's no change here. Okay, so make sure you guys pay attention to that. And then record your observations in the data table on the next slide. And then repeat steps 3 through 4. So you guys are going to test the rest of these objects until you guys find something. Another one that reflects and another one that transmits, and then 2 more that transmit. So here's how you fill out the table. You need 2 that transmit, so you'll fill out this first one that transmits. Reflected, for this one I put material tested, I'd put plant. Okay, what happens to the energy in the light? It reflects off the plant. And then did the material change? No. Okay, so remember you get that from going to inspect. Okay, and then I would find another one that reflects and fill that out here. And then I'd find one that transmits and a second one that transmits and fill that out here. Okay, so you guys can go ahead, take a second, pause this video. You guys can complete that data table and then answer this question. Use your observations from the sim to answer the investigative question. What happens to energy when light is transmitted through or reflected off a material? So remember, when energy is absorbed, the energy goes, or excuse me, when light is absorbed, the energy goes into that object. So what happens to the energy when it's transmitted or reflected? Okay, so again, go ahead, answer through slide 11. And then we'll move on to activity 5. Okay, activity 5 is a little reading activity, and this really goes along with our electromagnetic waves activity that we did the other day, where you guys kind of learned how an object appears to be a certain color and then also how our eyes perceive that color. So this article kind of tags along with that, and you guys get to see, all right, why when we look at this purple water bottle, does it show up purple? Okay, what is our light seeing that eyes seeing that interprets that light coming off that water bottle as purple? So read about what your eyes can see. Okay, do a good job. This is an interesting article. Okay, and it really does a good job explaining why you guys see certain colors. And then answer these 2 questions. When visible light shines on a black object, it gets warm because. And when visible light shines on a white object or a clear object, there is no change because. So explain what's happening with reflection, absorption, and transmission there. Okay, and then go ahead, take a second, pause this, finish up activity 5 reading and the 2 questions, and then we'll go on to activity 6, which is your homework. Okay, really easy little homework to finish up. It's only one slide long. You guys are just revisiting this image from earlier. So now that we've done a little bit of exploration with what happens with energy, I want you guys to re-answer this question. If we have a light bulb shining on the aluminum foil and it's reflecting off, okay, the image above shows the light from a light bulb reflecting off aluminum foil. Although the light is being reflected, do you think the aluminum foil will get warm? Maybe you were right the first time. Maybe you figured it out the first time. Okay, if not, use what you guys learned in the last couple of little activities to tell me whether you guys think it'll get warm, and again, explain your thinking. Okay, finally, extra credit option for you guys. You have another article to read, Making Waves at Swim Practice. Okay, so you guys are looking at obviously water waves and how they compare to like light and sound waves. So read that article and answer this question. Maybe you read that light waves travel through air and water at different speeds. What is one way this can affect what you see around you? So if we're looking at light waves, okay, if we're looking at water versus air, how's that going to change what you see? Okay, so answer that question. It'll be worth 1 extra credit point on your assignment. And then when you're done, go ahead, complete your wrap up. Make sure it saves before you guys hand it in. And you guys are all done. I hope you guys have a great day, and I'll talk to you soon. Bye.